So good evening all. So this is your new session for mass spectrometry after knowing some selective mass spectral pathways. So after knowing mass spectral pathways in mass spectrometry, we also discussed about what is mass fragmentation rules. So first rule is especially for alkane we learn, then for branched alkane, then for cycloalkane, alkyl cycloalkane, then we also learn about alkene, retro Diels order reaction, triple bond, then after triple bond halogen heterocycle compounds. So few selective rules we discussed, okay, even for aryl halides, benzyl halides. So characteristic fissions we learn, okay. So take few more fragmentation rules for individual functional groups so that each and every fragmentation will be cleared, okay. Right, next, after benzylic cleavage, so what is the characteristic fission of benzyl? Any alkyl benzene is present, benzyl cleavage is a characteristic fission, okay. Next, C, this is Mclafferty rearrangement. Mclafferty rearrangement. So this is a rule most commonly applicable for unsaturated molecules. Fragmentation rules, Mclafferty rearrangement. So what is Mclafferty rearrangement? Right, C, transfer of gamma carbon hydrogen followed by beta homolysis. Transfer of gamma carbon hydrogen followed by beta homolysis around unsaturated functional group. Around unsaturated functional group. Here I am taking a unsaturated functional group. There we are transferring this gamma carbon hydrogen followed by beta homolysis, that is called Mclafferty rearrangement. Okay, Mclafferty rearrangement, we are transferring, what we are transferring? Gamma carbon hydrogen. And where we are cleaving? Beta hydrogen, and this hydrogen we are transferring around unsaturated functional group. So this is also called NAR-2. If you know Mclafferty, NAR-2 is very easy for you. Okay, so we are transferring gamma hydrogen and we are cleaving beta. Okay, so what they produce? Mclafferty, they produce olefin and enol. Enol and olefins are resultant answer here. Enol and olefins are the major products in Mclafferty rearrangement. So this is Mclafferty C, 11th rule. This is C double bond O R I am using. This is alpha, beta, gamma. Okay, so this is generating a molecular ion after electronic impact. Now see, this is gamma hydrogen, alpha, beta, gamma carbon, gamma hydrogen. So break this bond and this bond. Then this carbon becomes double bond. Then this radical, there is a double bond or not, and this oxygen carry radical cation lone pair, and your hydrogen will be added here, and this is en and enol. This is called Mclafferty rearrangement. So if you break this radical will take this hydrogen. This radical combine together and forms double bond, and this radical also double bond. This is called Mclafferty rearrangement. Transfer of gamma hydrogen followed by beta homolysis. Here we are breaking or not? So what about this bond? Alpha. What about this? Beta. I am breaking beta bond. I am transferring this hydrogen on unsaturated part. Okay. Simply this alpha carbon and this put double bond, and here you add one hydrogen, that becomes a enol. And this carbon, beta, gamma carbon, put double bond. Every time beta carbon, gamma carbon, put double bond. Alpha and this carbon, write down double bond. So this is called Mclafferty rearrangement reaction. So what is your final answer? There is a formation of olefin and enol. Olefin and enol. This is alpha carbon initially. Then what is this? Beta carbon, and what is this? Gamma. Every time try to migrate one hydrogen from gamma. Put double bond between beta and gamma. Say I am transferring hydrogen from gamma or not? And I am breaking it beta. So beta gamma break and put double bond. Hydrogen try to transfer from gamma to unsaturated functional group. This is called Mclafferty. This is possible only for molecule having at least one gamma hydrogen. If gamma hydrogen is not there, unsaturation, if this unsaturation is not there, Mclafferty is not possible. Clear? Right. So most commonly Mclafferty fragmentation is a base peak for maximum molecules. Most of the molecules, if they carry unsaturation, this fragmentation becomes a base peak. Is it odd electron ion or even electron ion? Odd electron ion. Now see, this is neutral, odd, radical cation. So here see, molecule required at least one gamma carbon hydrogen. If gamma carbon hydrogen is present, then only it is possible. If you are saying gamma means it is unsaturated. If there is no gamma carbon hydrogen, no reaction, no Mclafferty. Okay, so mostly they are base peaks. Mclafferty rearrangement fragmentations are base peaks in most of the functional groups. Okay, Mclafferty fragmentations, they are base peaks in most of the fragmentation. Which molecule will give Mclafferty fragmentation? So you may expect a olefin. Then we can also take a triple bond, alkyne, aromatic hydrocarbons. Aromatic hydrocarbons. Then even we can take aldehyde, ketones, carboxylic acids and derivatives. What is the meaning of derivatives? What are carboxylic acid derivatives? Carboxylic acid derivatives. What are carboxylic acid derivatives? Ester, acid halide, amide, anhydride, nitrile, these all are called acid derivatives, carboxylic acid derivatives, because they are coming from carboxylic acid itself. Okay, so what is the requirement for this? Everywhere there is a requirement of, what is the requirement? There is a requirement of unsaturation and gamma. If unsaturation gamma carbon hydrogen is present, then they will give Mclafferty rearrangement. Okay, so you try this. This is aldehyde. Now if I do electronic impact, what will you expect? Mclafferty. See, if I do lone pair of electrons, see this is 70 electron volts. First what happens? You will get radical cation, right? Is this having any radical cation? Alpha, beta, gamma. Here gamma hydrogen is present. So can I break this bond? Break this bond, break this bond and this. After formation of molecular ion, then write down the answer. So what is your product? So can I write double bond here? Double bond. And here put double bond. And here you write down OH. Your hydrogen will be as it is. And this is radical cation and lone pair. So what is implicit value of this fragment? Implicit value. You should be very fast. 40. 1, 2, 3, 36. 36 plus 4. Every oxygen 4, not 2. Every nitrogen 2. 1, 2, 3, 36 plus 4, 40. 42. And here 2 more hydrogens. Here 2 hydrogens are there or not? Here, see, this carbon carry 2 hydrogens. So MZ value is 44. Is it aldehyde or ketone? Is it aldehyde or ketone? Aldehyde. So when aldehyde having gamma hydrogen, gamma carbon, then they will give base peak at 44. You remember this one. Aldehydes will give a base peak at 44. That is a Mclafferty fragmentation peak. Suppose if I take ketone, can you give the answer for this? This is ketone. Here radical cation, give the Mclafferty fragmentation. Out of all fragmentations, Mclafferty is very, very important. Now give the answer. What is this? Alpha, beta, gamma or not? Can you break it beta? Alpha, beta, break here. Break this hydrogen and break this bond. 3 breakages. Multi-center, single step fragmentation. Then what you will expect? Double bond. And what is this? Double bond. Here radical cation and this is methyl group. So is it radical cation or not? What is MZ value? See what is the difference between this and this? CS3 or not? Here hydrogen is there but here CS3. So if you remove this hydrogen, if you put hydrogen here, methyl here, then we need to add 14. 54 plus 14. How much? 68. 58, sorry. Like that. Is it ketone? Yes, ketone. Now, give the mass fragmentation of this one. This is aldehyde and this is methyl. Here this is radical cation. What is the Mclafferty fragmentation? First you write alpha, beta, gamma. Then break it beta. Put double bond at alpha and beta like this. Okay, put double bond here, put double bond here. So you will get double bond and here one more double bond and here radical cation and this is hydrogen and this is methyl. So what about MZ value? Same. MZ value remains same. MZ value 58 for this one even. But this is aldehyde, it is also aldehyde or not? But what is the difference? This is aldehyde, it is also aldehyde. But see, this aldehyde alpha carbon having no substitution, but here alpha carbon having methyl. That's why you got 58. So try this. This is ketone, here radical cation and here ethyl is there. Apply Mclafferty rearrangement. What is the answer? Right side there is no gamma, left side gamma is there, alpha, beta, gamma. So can I write double bond here? This is double bond between these two. So this side and this, you put hydrogen, a radical cation, and this ethyl is as it is. Right? Here methyl is there, now it becomes a ethyl. Then means 58 I would like to add 14. 58 plus 14. 72. Like that. Suppose if I take carboxylic acid, this is carboxylic acid, here this is the one. Apply Mclafferty fragmentation. Carboxylic acid, and here this is ester. This is OCH3, here radical cation, Mclafferty fragmentation. Acid ester, and this is amide. Mclafferty fragmentation, acid halide. Okay, then double bond. See, this is a double bond. 70 electron volts I am applying. Give the Mclafferty fragmentation for double bond. You target alpha carbon and unsaturation. You will get very easy answers. Alpha, beta, gamma. Now, can I put double bond here? This is double bond. Beta, gamma. This is beta initially, gamma. Alpha and this put double bond. You write OH and here one more OH. This is radical cation. MZ value? So Mclafferty most commonly asking in exam. It can also helpful for photochemistry, NRS2. So here, can I break this? Put double bond, and here you write down OH radical cation, and this is OCH3, right? And here also remains same. This is double bond. Put OH radical cation, here NH2, and here also same. Can I write double bond? Radical cation, chlorine. Will work out? Now, see in this case, so when you remove one electron from double bond, you will get radical, and this is cation. Is it unsaturated or not? Unsaturated alpha, beta, gamma is there. Now, after getting molecular ion, then break this. This is alpha, beta, gamma. Break this bond. So if you break here, this hydrogen is added here. If hydrogen is added, now here becomes hydrogen. Now this cation as it is or not? This is cation. And what about here? Radical. And what about this part? This part is removed in terms of olefin. Clear? Is it a unsaturated double bond or not? Double bond having gamma carbon. If double bond having gamma carbon, itself undergo Mclafferty rearrangement. Double bond having gamma carbon or not? See, alpha, beta, gamma. Gamma carbon having hydrogen. This hydrogen you migrate here. After formation of molecular ion, migrate this hydrogen from here to here. Put double bond between these two. So, this is radical, and what is this? cation, radical cation. So don't compare this one, because here we are removing electron from non-bonding, but here we are removing electron from pi. That is the difference. Mclafferty is most important for your examination. Out of total concepts of mass spectrometry, Mclafferty is most important because it is also related to Norris 2. Okay, and even in pyrolytics in elimination, indirectly it is possible to us. Many reactions are there which are linked with Mclafferty. And advantage of Mclafferty is almost all in all functional group these reactions are possible. Direct Mclafferty, indirect Mclafferty is also there. I will show indirect Mclafferty, but this is a direct Mclafferty. What is the requirement for Mclafferty? There is a gamma carbon is mandatory. Gamma carbon hydrogen, not only carbon, hydrogen is required. Then definitely molecule required unsaturation. If there is no unsaturation, no Mclafferty. Mclafferty not possible if molecule having no gamma carbon hydrogen, no unsaturation. Without unsaturation, without gamma carbon hydrogen, no reaction. Suppose, will you write Mclafferty fragmentation for triple bond? Right. How to write Mclafferty fragmentation for triple bond? This is alpha, beta, gamma. Where should I remove electron? From triple bond or not? If I remove electron from triple bond, you will get double bond like this. Right? So, suppose if you don't want to write like this, put inverted L and write down radical cation. That is also possible. Alpha, beta, gamma. So I would like to break this and this, then put double bond. So this radical and this carbon carry double bond. Radical cation. Can I write radical cation? Then what about here? This radical take this hydrogen or not? So this carbon carry how many hydrogens now? 2 hydrogens. Already this carbon having how many hydrogens? 1. Already 1 hydrogen is there. So I am transferring this hydrogen over here. You will get this one. So this molecule you can also write like this. This fragment N. See, here I can write double bond, and this is carbon, here double bond, and you can also write like this. See, if I write radical cation, which indicates it is a double bond, and write on outside like this. This and this both are same. Allene, propadiene. This is called allene, also called propadiene. What is implicit value? First. Here 2 hydrogens, 4. 36 plus 4, 40. Like that. So don't think that definitely heteroatom is required. Without heteroatom also reaction is possible. Now see this. 70 electron volts. What is Mclafferty rearrangement? So how to write? This is radical cation, double bond I am writing. Now what is this? Alpha, beta, gamma. Then how to write the answer? Can I break at beta? Can I break this hydrogen? Then what happens? Radical cation. So I can write double bond here, double bond here. This radical combined with hydrogen and forms hydrogen, and this is 1. So this radical and this forms double bond. And can I write outside like this or not? See, you can write radical cation. Like this also you can write. Like this you can also write. That is also acceptable. Here cation, radical. Suppose if you don't want to write like this, put double bond here between the two, write down outside. And what is removed here? Methyl is removed, olefin. Clear? Every time write down M/Z values for any positive charge species. You practice M/Z values. So what I would like to say is, Mclafferty required unsaturation, Mclafferty required gamma carbon hydrogen. So if these two are not present, no reaction. So will you give answer for this? This is nitrile, carbon nitrogen triple bond. So 70 electron volts, you will get molecular ion. Molecular ion formation takes it Fourier. Then what is your answer? What is Mclafferty rearrangement in this one? Is it alpha or not? Alpha, beta, gamma. First break bond between alpha, beta. This is called beta bond cleavage. Now gamma, hydrogen transfer. Break this. So here what happens? You will get double bond. Now here this carbon, double bond. And here carbon, nitrogen. Double bond or not? This is double bond. Now this radical takes this hydrogen. So can I write hydrogen on nitrogen? See. So if you break this bond, here you will get one radical or not? This is the radical, and here this is the radical. This radical, double bond. Here one more radical is left or not? This radical takes hydrogen. So nitrogen carry radical cation or only radical? Radical cation. Because it is an odd electron. Odd electron gives odd electron in neutral. Clear? Clear? Is it easy? Now take one question. See, which of the following does not give Mclafferty rearrangement? Mclafferty. See, it is also called fragmentation, also called rearrangement. Two names are there. Mclafferty fragmentation or Mclafferty rearrangement, both are same. So which will does not give, I am saying. Okay. So this is a molecule A, B, Option D, all. Which is not possible to give Mclafferty rearrangement. Which will not give? A and C will not give. B can give because alpha, beta, gamma. Like that questions they may give. Only Mclafferty fragmentation question is possible. Which will give Mclafferty fragmentation, which will not give. Like that. Which of the following does not give Mclafferty fragmentation? Which will not give? Answer is all. All will not give Mclafferty because there is no gamma carbon hydrogen. This is beta. Carbon is there, but that carbon having no hydrogen. Benzene. Benzene connected to this beta carbon. See what is pH indicates? Benzene. Like this, benzene is present. Now this carbon having no hydrogen. So this is alpha, beta, this is gamma. Gamma having no hydrogen. So that's why no Mclafferty. And tertiary butyl is this. This and this both are same. Alpha, beta, gamma. This is gamma. This part is called tertiary butyl. Okay. Then this is unsaturation alpha, and what is this? Beta. What is the requirement? Gamma is required. So there is no gamma, no reaction. Finally, all. All will not involve in Mclafferty. Clear? Right. Which of the following gives Mclafferty fragmentation? Which will give Mclafferty fragmentation? All will give Mclafferty. Clear? What is the answer? That is B. So where you are targeting? Gamma carbon and unsaturation. That's why see the definition. Transfer of gamma carbon hydrogen followed by beta homolysis. That point if you remember you can attempt Mclafferty question. Unsaturation is mandatory. Gamma carbon hydrogen is also mandatory. So this is alpha, beta, gamma. Here gamma carbon is there. Alpha, beta, gamma. Gamma carbon is there but there is no hydrogen. We can ignore it. Hydrogen is not there. Carbon is there but hydrogen is not there. So we can ignore. Here only beta. Alpha, beta and here also only alpha. Okay, right. In mass spectrometry, pentanol undergoes fragmentation. Produce a base peak at 44. Produce a base peak at 44. Okay. So the fragment is, what is the fragment? The fragment is option A. In mass spectrometry, pentanol means aldehyde. Aldehyde undergo fragmentation that will produce a base peak at 44. What is the answer? A. This is given just now. Pentanol means how many carbons? 5 carbons. So this is 1. 1, 2, 3, 4, 5. So this is alpha, beta, gamma. A radical cation. This is under fragmentation. So this hydrogen if you migrate, break here and break here and break here. So you will get double bond and this is double bond. Oxygen carry hydrogen and this is hydrogen. So this is radical cation, M-based value is 44. Okay, right. One more. In mass spectrum, butanol and pentanol produce base peak H. Produce base peak H. Where butanol and pentanol will give base peak. 44. This is 58 C. 44 and 58. 44 for butanol, pentanol is 58. 44 and 58. This one. D. 58 and 44. Reverse. Butanol 4 carbons, pentanol 5 carbons. This is called pentanol. 1, 2, 3, 4, 5. 5 carbons are there. Pentanal. Al. Al nothing but aldehyde. OL nothing but alcohol. I am not giving alcohol. I am giving aldehyde. Then can you guess the answer? Where you will expect a base peak? See, what is butanol and what is pentanol? This is called what? What is this? Butanol, Al. And if I take this molecule, right side example, what is this? Pentanol. So this is butanol and this is pentanol. And if I break here, migrate this hydrogen, what will get? This is enol. Okay, and what about this? Here also you will get same fragmentation or not? This is the one. I am breaking here. But what happens byproduct here? Byproduct is simple olefin and here it is propane. That is the difference. But we don't want here. Because in mass spectrometry we are unable to identify neutral species. We are identifying only positive species only. So now these two, if you consider, what is implicit value for these two? 44. So answer is this. Both will give common base peak at 44. If you take this molecule, base peak is 44. If you take this molecule, base peak is also 44. Clear? Clear? In mass spectrometry, butanol and 2-pentanone. Butanol and 2-pentanone produce base peak at where it will produce base peak. Both will give 44, both will give 58 C. Same options 44 and 58 D. 58 and 44. If you know fragmentation rules clearly, then only you can attempt the questions. Otherwise, impossible. You won't identify the question first of all. Forget about answers. You won't identify the question. What is this molecule? First molecule? First molecule name is butanol. Is it butanol? 1, 2, 3, 4. What is the base peak for this one? M by Z value? How much? This is 44. Then what about butanone? This is butanone. 1, 2, 3, 4, 5. 2 butanone. So break this. Break this. Hydrogen you break here, break here. And if you use this, double bond, radical cation, and here this is methyl. So what about M by Z value? M by Z value 58. So one for 44, other for 58. 44, 58. In last question, I given butanol, pentanol. Now pentanone. That is aldehyde, now it is ketone. That is the difference. Way of asking is different. You are in a concept, but way of asking different. That's why you people will confuse. But very literally I am saying it is very easiest questions if you understand the concept clearly. Clear? So next, double Mclafferty. It is also called a rearrangement. You can also say fragmentation. Better you say fragmentation. You write always fragment because fragmentation, mass spectral fragmentation, I can say. So double Mclafferty rearrangement, otherwise double Mclafferty fragmentation. So what it means? 2 times Mclafferty takes place on one molecule. In one molecule, 2 times it is possible. That is called double Mclafferty rearrangement or fragmentation. See this. Here I am taking alpha, gamma, beta, alpha. This is double bond. Alpha, beta, gamma. This is radical cation. Alpha, beta, gamma. Alpha, beta, gamma. Now the question is, how many times should I do Mclafferty? 2 times. First time, left side. See, I am breaking this side. If I break here, I can remove this or not? Remove this. Can I migrate this hydrogen here? Then what will get? Double bond, and what is this? OH, and here radical cation, this one. And what is this? Alpha, beta, gamma. I am not writing this double bond. This part I am removing. Okay? So, this is undergo tautomerism. Every time enol undergo tautomerism. After tautomerism, you will get double bond. And here see, this is alpha, beta, gamma, and this is radical cation like this. One more time. This hydrogen comes from here to here. Keto enol tautomerism. It is a enol form. Now it is a keto form. Now see this. Alpha, beta, gamma. Then what is your answer? Mclafferty. So can I put double bond right side? And here it is OH, here radical cation, and this becomes olefin. Over. MZ value? 54 or 58? 58. Suppose if there is no methyl, 44. When you do 2 times Mclafferty in one molecule, that is called double Mclafferty. See, left side is also possible, right side is also possible. Step by step process. Clear? Over. Suppose see, if molecule having this side, see Mclafferty, double Mclafferty. How to do double Mclafferty? See, right side, left side, both are not same, right? Right side gamma carbon having methyl, left side gamma carbon having only hydrogen. So, which side you will do fragmentation first? Right side or left side? Right side. Whichever side gamma carbon having more number of substitutions, that will be initiated first. So if I do right side, first you break here and transfer this hydrogen from here to here. So can I write like this? This is double bond, and what is this? This is radical cation like this. Can I make tautomerism? If I make tautomerism, you will get double bond O, and this is methyl, radical cation like this. If I do one more time Mclafferty, then what happens? This is double bond, radical cation, and this is methyl, and olefin will be removed. Simple. If molecule having more than one gamma carbons, Mclafferty rearrangement initiated from that particular side where gamma carbon having more number of substitutions. So from here to here, first Mclafferty, then this is second Mclafferty. You got this? Will you work out this? Which side you will do first? Right side, then left side. Will you get same answer? You will get same answer. Thing is same, but which side you will do first, which side you will do second, that is different. This is double bond and this is pH. This is radical cation. So give double Mclafferty rearrangement. This is radical cation. This one, double Mclafferty. Give the answers. So first right side, left side. In this first left side, next right side. Okay. So when any ester is given, this is ester. This is ester. This side also alpha, beta, gamma is there. First oxygen side, next carbon side. First give priority for oxygen side. Because this bond dissociation energy is very less as compared to this side. So this I will show. So if I remove this, I can remove double bond, and here it is radical cation, and this is alpha, beta, gamma, right? I am breaking this side or not? This side I am breaking. You will get double bond here. This is OH. This is on tautomerism. After tautomerism, you will get double bond O, and this is OH. This is radical cation and this one. So alpha, beta, gamma. Now gamma hydrogen is there, here we can cleave. So if I cleave this, can I put double bond? So I can write double bond, and this is OH, and here one more OH, and this is radical cation, and there is a loss of olefin. Right? So break this side, put radical double bond, and this OH will be added here. Is it double Mclafferty possible? Yes. If more than one gamma carbons are present, give priority for that gamma carbon which carry more number of alkyl substitutions. Okay? Suppose if one side more reactive, other side less reactive centers are present, more reactive center we need to give priority. In case of esters, give priority towards ethereal oxygen side. This is called ethereal oxygen. Always give priority towards ethereal oxygen side. Clear? Right. Which of the following produce double Mclafferty rearrangement? Which will give double Mclafferty fragmentation? This is CSR question. They are not asking fragmentation. They are asking simply which will give double Mclafferty. What is the answer? That is C. Why this is not possible? There is no gamma hydrogen. Here, at least one time Mclafferty, not even one time Mclafferty. Here two time Mclafferty because gamma, gamma both are present. And here also remains same. Alpha, beta, gamma. Gamma carbon is present but not gamma hydrogen. So that's why, is it one time possible? Yes. Like this questions they will ask. So we are learning a core knowledge, but they will ask, most commonly in your exam they won't ask that much tougher. Only thing is, if you identify, you can pick the answer. Codes, whatever codes I am saying, based on that codes, he was giving questions very easily in exam. Clear? Next, indirect Mclafferty fragmentation. Indirect Mclafferty. Indirect Mclafferty. Now total three types of Mclaffertys will be there. Simple Mclafferty, Norris 2, okay, pyrolytic sin elimination under thermal. Then one more Mclafferty, double Mclafferty. Just now I explained. Now one more is indirect. So what is the requirement for Mclafferty? Unsaturation. One more is gamma hydrogen or not. So some molecules, they don't have unsaturation. During electronic impact they will generate unsaturation. After generating unsaturation, then they will involve in Mclafferty. That is called indirect Mclafferty. Directly they never involve in Mclafferty. Indirectly they will involve in Mclafferty. Such type of fragmentations are called indirect Mclafferty fragmentations. Is it clear? Okay. So see this. Especially I am taking a molecule of indirect Mclafferty with a oxygen, especially ether. See, gamma, beta, alpha, oxygen. Here alpha, beta I am giving. Is this molecule undergo Mclafferty rearrangement? If I do 70 electron volts, it is impossible to give Mclafferty, right? Why? Why they doesn't involve in Mclafferty? There is no unsaturation first of all. See, this is alpha, beta, gamma, delta. It is also alpha, beta, but there is no unsaturation. It is impossible to write Mclafferty. But what happens is suddenly, during electronic impact, molecule generates radical cation. It is further undergo fragmentation to give unsaturated molecule. See this. This side, I am breaking this bond. This is fragmentation. Now this radical combine together and forms unsaturation. 1, 2, 3, and this oxygen connected to this carbon CH2, and this is positive and here lone pair, and what is present? There is a presence of methyl radical. Now unsaturation is present or not? Now this molecule I am writing conveniently. See this. This is CH2. This is oxygen. Alpha, alpha, beta, gamma. Alpha, beta, gamma, delta. Alpha, beta, gamma, delta. Now this is positive. Now skeleton is ready or not? Unsaturation is there. Unsaturation, gamma carbon hydrogens are present. So I can do Mclafferty easy. So what is Mclafferty right now? How to do? Break bonded beta, alpha beta. Now break here, break here. Can you write the answer? Carbon oxygen carry double bond, and this carbon carry CH3, and here positive charge, and what is removed here? Double bond outside is removed. This is called indirect Mclafferty. Some molecules are there, they doesn't carry unsaturation, but after electronic impact, after fragmentation, they will generate in middle unsaturation. Initially they don't have unsaturation. After fragmentation, fragment molecule undergo unsaturation. That unsaturation responsible for Mclafferty. This is called indirect Mclafferty. So one more example, see. See, this is halogen. It may be chlorine, bromine or anyone. Okay. So this is on electronic impact. There is a formation of radical cation like this. Okay. So here one of the hydrogen is going to be broken Now this radical forms double bond. So this is double bond plus lone pair, right? I removed hydrogen here now. So then what is this? Alpha, beta, gamma. Can I transfer gamma hydrogen followed by beta fission? So this molecule can I write like this for your convenience? Gamma, beta, alpha. This is double bond, here X, radical cation like this. Can I? See, if I break this one, you will get double bond or not? Here only plus lone pair. So here it is only plus cation. Now this is alpha, beta, gamma. So can I break this? And I can also break this hydrogen. So break this and break this. Then what is your answer? So can I write like this? So this is double bond and here X carry one hydrogen. Okay? And here lone pair, and this is plus. Right or not? See? This radical, double bond. This radical and this hydrogen forms a single bond. So lone pair and positive charge remains same. This fragment also possible. Indirect means it is C. What is this fission here? C. Is it alpha homolysis or beta homolysis? Beta. Yesterday I given C. Yesterday I think 7th or 8th selection rule. Halogens, heterocyclic compounds, oxygen, nitrogen, heteroatoms, alpha heterolysis, beta homolysis possible. First characteristic fragmentation is over, then name reaction. Clear? Next. This is called onium ion fragmentation. Onium ion fragmentation. Up to now we learn what is Mclafferty, double Mclafferty, indirect Mclafferty. From this you may expect a question. Suppose whenever examiner want to give any question from mass spectrometry, first they will think about mass spectral pathways. Okay? Then next they will think about Mclafferty, direct or indirect. Okay? Then they will think about isotopes. Any isotopic question, either chlorine question or bromine question, M+2, M+4, their intensity, this year intensity question is given. Okay? So only these three areas questions are possible. Maximum these three areas only. But this is almost all heart of many concepts. Some name reactions and some photochemistry questions, some selected areas, mass spectrometry can be helpful. But expect a straightforward question only from Mclafferty. or any isotopic peak. Intensity question you may expect. Clear? Now, what is onium ion fragmentation? What is Mclafferty fragmentation? Are you listening these all topics in your PG? Any question, same expression. Are you listening these concepts in your PG or not? Mclafferty, 100% they will explain. Because it is most important for your examination. I think so. Right? So mostly double Mclafferty, indirect Mclafferty, not that much intensively. But they will explain definitely Mclafferty. But rules they won't explain. Directly they will go for hydrocarbon, alkene, alkane, alkane. So that mass spectral pathways they won't explain. But that is a secret to understand mass spectrometry. If you know that secret clearly, if you know nitrogen rule, what is odd electron, even electron clearly, mass spectrometry is nothing. But from the last 4 years, what we are observing is, 4 marks or 2 marks is compulsory. They are asking separately from mass spectrometry. Earlier, they are not asking. So previous years, if you go through last from the 3 years or 4 years, they are asking indirect questions. Okay, sometimes 4 marks question directly they are asking. Direct mass spectra they given. Mass spectra 1, complete spectra on question paper booklet. Then they are asking below fragmentation. So you expect a HNMR question, data. So they will give complete chemical shift value as well as coupling constant values. One complete data they will give, below they will give 4 options. So that 4 options are 4 different molecules with some differ in their chemical shift value, coupling constant value and number of signals. So these 8 marks will be in your hands if you prepare HNMR as well as mass spectrometry. Sometimes they won't ask any question from UV, any question from IR, but definitely one question 100% one question from HNMR. HNMR or C13. It may be a signal calculation or it may be a coupling constant values and chemical shift value calculations. So if you familiar with coupling constant, chemical shift value, then you can identify an organic molecule clearly, because in your syllabus in CSR, only he was mentioned that structural determination of organic compound. Only that you can determine clearly. Is it clear? Now, onium ion Mclafferty is what? Gamma hydrogen transfer, beta homolysis. What is onium ion? Beta hydrogen transfer, alpha homolysis. Beta hydrogen transfer, alpha homolysis. What is Mclafferty? Gamma hydrogen transfer, beta homolysis. See the difference. If you reduce one, onium. Onium nothing but any positive charged species which involve in beta hydrogen transfer, alpha homolysis. Gamma hydrogen transfer, beta homolysis is Mclafferty. Beta hydrogen transfer, alpha homolysis is onium ion fragmentation. This is given by a oxonium, ammonium, IUM. See, onium. Onium nothing but it may be a oxonium, ammonium. Here onium nothing but it is not a name. It is not a name of a scientist. If any organic molecule having nitrogen in the form of positive charge, oxygen in the form of positive charge, they will show onium ion fragmentation. It is almost all equal to Mclafferty, but only one carbon is going to be reduced. Clear? Right. Write down. Transfer of beta hydrogen, beta carbon hydrogen, followed by alpha homolysis. Alpha homolysis in transfer of beta hydrogen followed by alpha homolysis in oxonium ions or onium ions. In onium ions. What are onium ions? Ammonium or oxonium. Ammonium, oxonium. See this. Onium is called onium ion fragmentation. It is very simple. Onium ion fragmentation, transfer of beta carbon hydrogen followed by alpha homolysis on onium ion. Now onium ion is nothing but ammonium or oxonium. Okay, so this is that molecule. This is nitrogen, and here I am writing 2 carbons. Okay, here one lone pair of electron is present. Now 70 electron volts I am using. Here there is a formation of radical cation. You will get like this and break this bond. If I break here, what you will expect? Radical. This radical, this radical. Double bond or not? So if I create a double bond here, this is double bond 1, 2, 3, and this is positive charge, right? Clear? Now if you observe clearly, this is unsaturation. Unsaturation, first carbon is called alpha. Next carbon is called beta. So here beta, how many hydrogens are present? 2 hydrogens. So one of the hydrogen I am writing separately. Now what about this bond? Alpha. What is this? Beta. So alpha homolysis, beta hydrogen transfer. It is looks like Mclafferty or not? Almost all. Only one carbon we are shifting. These 2 we are shifting here. That is called Mclafferty. If you know Mclafferty, no need to remember onium ion fragmentation. So these 2 carbons carry double bond or not? This radical double bond. Now this hydrogen migrate from here to here. Right? See, if I break this homolytically, here one radical is left, here one radical is left. This radical double bond, this radical comes and joins here. So on that time, here nitrogen carry 1 hydrogen, then 1, 2. And what about this? This is positive charge. That is the answer. Now is this molecule having one more time hydrogen? See, this is unsaturation or not? What is this? Alpha. What is this? Beta. Now one more time, can I do fragmentation or not? See this. Beta carbon, I am breaking this hydrogen. I am breaking this bond. Okay. So this radical join together. 2 times onium ion fragmentation. So then what will you expect? Here nitrogen carry double bond, and here hydrogen. Can I put one more hydrogen here? This is hydrogen. And what is left here? Olefin is left. Olefin is left. And here hydrogen is added here. How many times onium ion fragmentation? 2 times. Suppose if this group is not present, only one side it is possible. So now 2 times I am doing. Already this side also beta carbon is present. Left and right. Left side, right side, both beta carbons are present. I am choosing right side. Why I selected right side? Because here I removed a olefin which carry more number of hydrocarbons. That is methyl. If any double bond having methyl, it is stabilized by hyperconjugation. That's why right side. Even same reason for double Mclafferty. Clear? Right. So what are the functional groups involved in onium ion fragmentation? Ammonium, oxonium. Okay. One more example I will show. See, this is oxygen, carbon, here two other carbons are given. This is lone pair. 70 electron volts, there is a formation of radical cation like this. Now, here if I remove one hydrogen here, what is this fission? Beta homolysis. That you need to identify. Which is alpha bond, which is beta bond, which is type of fission. If you identify, almost all concept is closed. So I can put double bond between carbon and oxygen and you will get positive charge. Here lone pair 1, 2. Then what is this? Alpha, beta. Now beta carbon having one hydrogen and here see, break this and break this. Then what is your answer? This hydrogen comes and joins on oxygen. So oxygen carry one hydrogen and these two carbons carry double bond over. See, I am doing this rearrangement after formation of molecular ion, one fragmentation or not. So from here to here, what you are expecting? This is molecular ion. Molecular ion losing one hydrogen. So I can say M minus 1. Is it M minus 1? Now you will get one molecule. So what is MZ value of this one? See, this is 12 and this is 16. 28, 28, 31. MZ value is how much? MZ value is 31. So they will give a clue like this. A molecular ion gives a peak at M minus 1 followed by 31. Identify the fragmentation. Clear? So that is about few fragmentation rules up to onium ion. So Mclafferty, double Mclafferty, indirect Mclafferty, onium ion we discussed. So in your next class you will see how to make fragmentation in a carbonyl compound. What are the major fragmentation modes are observed in carbonyl compound. So after carbonyl compound we will see what is ortho elimination. Ortho elimination. So that is also very important one. Then followed by what are the fragmentation elimination reactions are observed, such as dehydrohalogenation, dehydration, decarbonylation and 1,4 elimination reaction, etc. Okay, because some molecules have a tendency to lose some neutral fragments. So what kind of neutral fragments are possible to remove from a given organic molecule will be discussed in the mass fragmentation pathways, that is mass fragmentation rules. So that we are going to discuss in your next class. Okay, we'll stop here. So if you know pathways clearly, individual functional group discussion is very easy for you. So only in that case we will see what is a base peak and what is a fragmentation peak. What is the most common peak in mass spectrum, that we will discuss directly. Clear? We'll stop here. So up to 23rd there is no inorganic and physical chemistry classes. After 23rd we are planning to conduct inorganic as well as physical chemistry classes. Okay, only 2 more days will be there. So there you will see one more additional class, inorganic and organic, or organic or physical, like that, and time will be extended up to 8:30. That we are going to announce later. Okay, in February we are planning to conduct examinations. So in January there is no, every starting of the CSR batch, first month completely we are going to explain a concept so that students will engage the concepts clearly. They can understand the concept, they can understand some little bit basics. So that's why first month we are not going to conduct any kind of examination. There is a slight change in timetable also, regularly we are going to observe. But second month, once if you enter into second month, this kind of disturbance will be not observed. Okay, so time will be 5 to 8:30. Okay, and 2 classes will be there. Sometimes only one class. Suppose if only one class is there, that will be extended up to 8 o'clock, 5 to 8, like that. Okay, we'll stop here. Close this.